So yesterday we were looking at like scales, and if you have this distance on the scale, what is it in real life? Or if you have this distance in real life, what is it in the scale? Or using those two numbers to set the scale. Today we're going to actually be doing some calculations with that, and it kind of ties into our cross-multiplying and dividing that we were doing in the last chapter. First thing I want to write down is a scale drawing. So scale drawing. And for a scale drawing is basically you're just drawing something at a new size, but it has to have the right proportions still. So drawing something at a new size, but with the same proportions. In other words, it's going to look the same. It's just going to be bigger or smaller. But it's not like you're going to take somebody's face and turn them into like something like scrunched sideways, like they just got hit by a car kind of face. When you're looking at the units then, so I want to say scale units. So scale units. For those, when they're the same, you can just drop them. So can... There's two words. You can drop them. You can drop them if they're the same. In other words, they cancel out the same. I'm just going to quick throw down an example, have that hopefully make sense. So in other words, if you have something like 1 inch equals 4 miles, so 1 inch equals 4 miles, then you need to keep the units. Where if instead you had something like 1, maybe I should do inches this way. You guys used to the quotation marks, that right there standing for inches? Okay, so at least some are. If you have instead like 1 inch equals 5 inches, then you can drop them. So for that you can write, just instead of that, you could just do a 1 to 5 because the units are the same. Or if you wanted to, you could write it as a fraction even and say, or 1 over 5. So same units, you don't need to include the units, you just can say 1 to 5 or 1 to 4. But if you have like inches equaling miles, then you have to do something different. Make sense? Cool. Give people a second to copy that down. Then we'll flip to the next thing. What's the next thing is like setting the scale, and I'm going to put this in red for dramatic emphasis. This is important. So if I take and make this a little bit smaller. So this next thing then, the scale for something is going to always be the new size divided by the original size, or you could maybe say old if you wanted to make it a little bit shorter. Original size. So in other words, when we go from, in our picture here, this middle pig is the original. If you have something that's twice as big, it's twice as high, it's twice as wide, it's going to be the new size of 2, maybe you measure it, it's 2 inches tall, the new one, compared to the 1 inch tall on the other one. So it's going to be a scale change of 2, or really a size change of 2. You see here, they wrote it as a ratio, they wrote it as 2:1. And that's the same way that you could, if you wanted to, in this red, say, instead, scale equals the new size, colon, the original size. Which, if you go back to the last chapter, that's the same way we were doing ratios before. That if we would have a ratio of 2 to 1, like this here, 2 to 1, that'd be the same as the fraction of 2 over 1. So no change, just kind of another application of what we were doing in the last chapter. If you go in the reduction way, so if instead you start with this original pig and you're going to this one, now maybe the size here you could say is like 1 centimeter, so if that's 1 centimeter, if the original pig now is 2 centimeters tall, this here it's a scale of 1 to 2 that way, or a 1/2 for a scale. Seem fitting? So no questions on that? All right, then if we jump ahead, so I want to go through and do an example here. So move this guy over, and we'll say example 1. So example 1. if the scale is 1 inch equals 1.5 feet, so if the scale is 1 inch, I guess I could do the inches, 1 inch equals 1.5 feet. Do I need to keep the units or can I get rid of them? Keep them because they're different. Nice. So how large is the car in real life? So how large is the car in real life? And I just grabbed a car offline because I don't have any model cars, although I guess I could have had my son make one out of Legos. But if you wanted to find this out, if you're trying to figure out how large, I'm thinking like lengthwise. So if you want to fit this in your garage, how much room is there for your bikes in front of the car? So what do I need to measure on my little drawing? Yep, measure from one to the other. So if we were to take, and I'm just going to say, I measure from here to here, and we'll say that that's going to be, if I try to use my finger, I'm going to say that's going to be 2.75 inches. So 2.75 inches. And we know the scale is 1 inch equals 1.5 feet. So say we want to now figure out, well, how big is the car going to be in real life? Well, if I take this, 1 inch equals 1.5 feet. That's the same as saying like 1 inch colon 1.5 feet. But if we wanted to write that as a fraction, we're going to put the 1 inch in the numerator, the 1.5 feet in the denominator, because that would set it up nicely for the scale type of problem. Now when I have my 2.75 inches that I measured for the car down here, if I'm making a proportion, does that have to go in the numerator, have to go in the denominator, or does it matter? Have to go in the numerator, because that's where the units are also inches. That if I have inches in the top of the other one, I need to have inches in the top of the second one. And now we're trying to figure out, well, how many feet long is it in order to get the real life thing. So when we have one like this, we cross multiply. So we're going to do 1 inch, or 1 times x, equals 1.5 times 2.75. Maybe I should be going through and actually showing my units too, because it's really kind of cool. The units will all drop out as you go through and do them. I'll probably skip it right now. But if I do my 1.5 times 2.75, somebody beats me to it, feel free to shout it out. All right, so I have 4.125, and that equals 1x. So we're done, really. If it was like a 2x, then you'd have to divide by 2. But since it's a 1, you could say, well, you divide by 1, but that's really not going to do anything. So you end up with just x equals 4.25. But it's 4.25 what? Feet. Because we found this thing here, that wasn't supposed to happen, we found this thing here, x, which is in the same spot as that other one. So our units have to be feet. So this is like a little tiny like smart car or something like that. Or a toy car, according to my scale. Does that make sense to people? So if that makes sense, you really can skip this last example, but I'm just going to do one final example. In that example, we're going to, it's basically real similar to the one before. But if I have this here, so you could draw a bolt like that if you wanted to, or really just draw an object like a rectangle or something, right, the 1.2 centimeters high. And I'm going to say, or maybe we can kind of write it in here, if the 1.2 centimeter object is enlarged, say we're going to do like a drawing, a CAD drawing of this thing here, and our scale is going to be 15 to 2, so same units, so I don't need to write units in my scale there, is enlarged 15 to 2 for a drawing. How large is the drawing? So how large, how tall maybe is the drawing? Sometimes I think it's helpful to label it, since we don't have different units. We could say, all right, I'm going to take my paper, how large it's going to be in paper, over my, what is it in real life. And the reason I put paper in the numerator is we said that it's a scale of 15 to 2. So 15 over 2 then equals, now we just need to figure out this 1.2 centimeters. Where does that go? Well, that's this bolt's height in real life. It's about a ½ inch. So then that has to go in the denominator. So I have my 1.2 centimeters here. And you could leave off the units if you wanted to, but what we're looking for is x. what's that height, how long is that going to be on the paper. And we go through and solve that just like we did the last one. We're going to cross multiply. So I'm going to do that, just keep my x on the right side. So I have 2 times x equals 15 times 1.2. If you want to put in the units, you can. And my 2 and my 15 were kind of like unitless numbers, so that's why I don't have units after them. And again, if the units are messing you up, you probably can just leave them off and know that your final answer will have the same units as your original question did, so it'll end up being centimeters. Here I have 18 centimeters. Last step then, because it's 2 times x, we divide. That's the inverse of multiplying by 2. And then I have x by itself on the left and 9 centimeters here. So that would definitely fit on a normal piece of paper. That's going to be right around 3.5 inches, something like that. That is all for this section.